This is group 5, and our topic, we're going to begin with maintaining the engine of human life. The human heart, one of the most important organs in the human body, beats approximately 72 times per minute. The heart pumps blood, which carries all the vital materials which help our body function and removes the waste products that we do not need. Some interesting facts about the heart is that it beats more than 100,000 times a day, pumping about 2,000 gallons of blood, and it's only the size of your fist. It's located between the lungs, behind your sternum, in between the lungs. It consists of 4 major chambers: the right atrium, right ventricle, left atrium, and the left ventricle. And there's a wall of muscle called the septum that separates the left and right ventricles into 2 cavities. The function of the right side of your heart is to collect deoxygenated blood in the right atrium from the body and pump it via the right ventricle into the lungs so that carbon dioxide can be dropped off and oxygen picked up. The left side collects oxygenated blood from the lungs into the left atrium. From the left atrium, the blood moves to the left ventricle, which pumps it out to the body. Here's a quick video.
Your heart is a pump. It's a muscular organ about the size of your fist and is located slightly left of center in your chest. Your heart is divided into the right and left side. The division protects oxygen-rich blood from mixing with oxygen-poor blood. Together, your heart and blood vessels comprise your cardiovascular system, which circulates blood and oxygen around your body. In fact, your heart pumps about 5 quarts of blood every minute, and it beats about 100,000 times in one day. That's about 35 million times in a year. Oxygen-poor blood, blue blood, returns to the heart after circulating through your body. The right side of the heart, composed of the right atrium and ventricle, collects and pumps the blood to the lungs through the pulmonary arteries. The lungs refresh the blood with a new supply of oxygen, making it turn red. Oxygen-rich blood, red blood, then enters the left side of the heart, composed of the left atrium and ventricle, and is pumped through the aorta to the body to supply tissues with oxygen. 4 valves within your heart keep your blood moving the right way. The tricuspid, mitral, pulmonary, and aortic valves work like gates on a fence. They open only one way and only when pushed on. Each valve opens and closes once per heartbeat, or about once every second. A beating heart contracts and relaxes. Contraction is called systole, and relaxing is called diastole. During systole, your ventricles contract, forcing blood into the going to your lungs and body, much like ketchup being forced out of a squeeze bottle. The right ventricle contracts a little bit before the left ventricle does. Your ventricles then relax during diastole and are filled with blood coming from the upper chambers, the left and right atria. Then the cycle starts over again. Your heart is nourished by blood too. Blood vessels called coronary arteries extend over the surface of your heart and branch into smaller capillaries. Here you can see just the network of blood vessels that feed your heart with oxygen-rich blood. Your heart also has electrical wiring, which keeps it beating. Electrical impulses begin high in the right atrium and travel through specialized pathways to the ventricles, delivering the signal to pump. The conduction system keeps your heart beating in a coordinated and normal rhythm, which in turn keeps blood circulating. The continuous exchange of oxygen-rich blood with oxygen-poor blood is what keeps you alive.
The conduction system in your heart. There are electrical impulses from your heart muscles that causes your heart to beat, which makes it contract. This electrical signal begins in the SA node, located at the top right of the atrium, which you can see in this diagram over here. The SA node is also known as the heart's natural pacemaker. because this is where the electrical impulse starts to create the contraction. When an electrical impulse is released from the SA node, it causes the atria to contract. The signal then passes through the AV node. The AV node checks the signal and sends it through the muscle fibers of the ventricles, also causing them to contract. Due to time constraints, we're going to skip the video and we're going to keep going. Complications of the heart. As we just learned in the conduction slide before, when the pumping of the heart is caused by electrical activity. When the sequence is disturbed, the arrhythmia is caused. An arrhythmia is an abnormal rhythm of the heartbeat. Arrhythmias cause the heart to pump less blood less effectively. Most cardiac arrhythmias are temporary and benign. Some people can grow out of them, like I had a heart murmur and I grew out of it. Types of arrhythmias. Tachycardia. This is an abnormal heartbeat that exceeds 100 beats per minute. You might have fluttering, racing beats in your chest, a little feeling weakness or dizzy. The treatments for these are intravenous medications, implantable defibrillator, or even surgery for extreme conditions. Bradycardia is an abnormally slow heartbeat. This is usually defined as a heartbeat that's less than 60 beats per minute. You may feel a bit tired, less sluggish, dizzy, and a lot of chest discomfort. The treatment for this is the pacemaker.
Heart is engine of human body, and when this engine start creating problems, then you need some treatment. One of the treatment is a pacemaker. And pacemaker is a small device that placed in the chest or abdomen to help control abnormal heart rhythm. It stimulates rhythmic heartbeat by means of electrical impulses, and usually it is implanted when the heart's own natural electrical conduction system does not functioning properly, and then basically this is pacemaker is placed in the body. The battery powered device emits impulses that trigger heart muscles contraction at a rate that is preset or predetermined by the doctors. It is very small device, 2.5 centimeters dia and 14 grams weight only, and more than 500,000 Americans are using this pacemaker device. It is basically developed in 1960, and pacemaker originally sent one steady beat to the heart, and modern versions can even monitor your heart activity, and it is only work when it is necessary. Who needs a pacemaker? Doctors recommend pacemaker for a number of reasons. The most common reasons are bradycardia and heart block. Bradycardia is slower than normal heartbeat, and heart block is a problem with the heart's electrical system. So there are some other reasons like sinus symptoms and heart medicines. When you are using heart medicines, they might slow your heartbeat. We have how basically we can use this and how doctors recommend this pacemaker. There are different tests, diagnostic tests on the basis of these tests. Doctors basically recommend this device. First test is the electrocardiogram, and this test basically painless test and detect and record the heartbeat, and then Holter event monitor. This test basically monitor your activity for a long time, like 24 hours to 48 hours. Then ECG basically use the sound waves, and then electrophysiology study and stress test. These are different tests. On the basis of these tests, these doctor can recommend all these tests or specific one or two tests to the patient. Types of pacemaker. we have different type of pacemaker, single chamber pacemaker, dual chamber pacemaker, rate responsive pacemakers, and demand pacemakers. Single chamber pacemaker basically use single wire in a heart chamber, and dual chamber pacemaker use two wires, one in atrium and the other in ventricle. Then we have our rate responsive pacemakers as well. These are basically automatically adjusted when required. Demand pacemakers are used when there is some electromagnetic interference. These pacemakers are used at that time. I just want to show you a video.
Implantable pacemakers and defibrillators are devices that apply electric shocks to maintain the rhythm of the heart and, if necessary, restart it. As the technology improves and the list of treatable conditions grows, the number of devices being implanted is increasing steadily and now exceeds 500,000 a year. The heart is made up of 4 chambers, 2 atria and 2 ventricles. On each side, the atrium is connected to the ventricle by a one-way valve. Blood is pumped as these chambers contract and relax in turn. The beating of a healthy heart is regulated by electrical impulses. The sequence begins as the atria fill with deoxygenated blood from the body on the right and oxygenated blood from the lungs on the left. An electrical signal from the sinoatrial node then causes the atria to contract, forcing blood into the ventricles. The electrical signal is then picked up by the atrioventricular node and directed into the Purkinje fibers in the ventricle walls, causing the ventricles to contract. And the blood is then pumped through the pulmonary valve on the right to the lungs and the aortic valve on the left to the rest of the body. These valves close and the cycle then restarts. When the sinoatrial node fails to function correctly, an artificial pacemaker can be fitted to help regulate the heartbeat with small, evenly timed electric shocks. This involves implanting electrodes into one or more of the heart's chambers by inserting leads into a vein near the collarbone and implanting a device called the generator just under the skin. For more severe heart conditions, an implantable defibrillator, or ICD, can be used, which is also capable of sensing a stopped heart and delivering an electric shock powerful enough to restart it. For some conditions, an even more sophisticated device, called a CRT ICD, can be implanted. This uses a third lead inserted into the left ventricle to resynchronize the ventricles when necessary. However, all these leads can cause problems of their own. Patients with ICDs have a 20% chance of a lead failure within 10 years, and replacing leads can require open heart surgery in about 2% of cases. This has resulted in several efforts to develop new pacemakers that do not depend on leads inside the heart. One design, the subcutaneous ICD, places the lead just outside the heart under the patient's skin. And wireless designs are now being developed that may eventually do away with the need for leads altogether.
So this is how a pacemaker works. Now you can explain more.
Good evening, friends. My name is Praneeth. I'm going to explain about different types of pacemakers and latest technological pacemakers that we are going to use. So before explaining about a pacemaker, let me explain a brief fundamental thing about a heart. It's like our brain has to say to our heart to pump, to pump the heart. Our brain has to send a signal to the heart to pump. So if SA node, there is a small part in the heart called SA node. If the SA node is not able to catch the signal from the brain, or if SA node is not working, then we are going to use the pacemakers. Previously, there are different types of pacemakers like single chamber, dual chamber, as my friend Rizwan has said. They were having a lot of problems because previous pacemakers, they used to keep wires outside the human body and they were having a lot of infections, all that stuff. But because the new technology, it's a rate responsive pacemaker, which you can see the size of the pacemaker. It's a real picture of the X-ray. It's like that's going to be the size of a pacemaker. I see pacemaker is an electronic medical device. This is this is used to send the electrical impulses to the heart if there is any irregular rhythm in the heartbeat. Okay. Okay. These are extremely programmable. Because heart rhythm, everything is going to be changed depending upon the age and situations and the problems of the patient. So this device is extremely programmable for us. So we can program. We can do that. We can keep a particular stored value in a remote, because it even have a remote control. So we are going to store all the particular values in that remote control. And okay, there are a lot of problems. There are a lot of there are a lot of problems which the heart has, and some of the problems doctors may recommend to keep the pacemakers is the sinus syndrome and AV block. AV block is nothing but atrium and ventricle block. Next slide. There are three important parts of a pacemaker. That is the electrical pulse generator, power source, and the lead system. I'll just briefly explain about each single part of it. Next slide. So, in order to give an electrical impulse, the pulse generator needs a power source. Power source is nothing but the battery. The lifetime of a battery is going to be 15 years or 20 years, depending upon the model of the pacemaker that we're going to use. And the lead system is connected to the heart, and the information about the heart is going to give the pacemaker generator through this lead system, and electrical pulse generator is going to decide whether to give the electrical impulse to the heart or not. So as I said, I'm saying lead. What is this lead? It's nothing but electrical connection between the pulse and the heart. There are two types of leads that we are going to use: the unipolar lead system and a bipolar lead system. It depends upon the problem the patient do have. Okay, as I said, in this technology, we use a lot of sensors. There are different types of sensors we use. Next slide, I'll just skip. They are the next slide. Activity sensors, metabolic sensors, breathing sensors, lot of sensors that they're going to use in this technology. Let me explain brief about the important sensors that they're going to use, that the activity sensors and the breathing sensors. The pacemaker is going to give the electrical impulse to the heart, but when it has to, the pulse generator has to know if I'm doing exercises or if I'm sleeping, if I'm doing working, the heartbeat is going to be different for different particular of time. The pacemaker has to know when what should be the heartbeat if the person is doing exercise, what should be the heartbeat if the person is sleeping. So there is called the activity sensors. If you are going to do some exercises, there is some piezoelectrical crystal which can capture the muscular waves of the human body, and it can give the information about the muscular waves to the electrical pulse generator, that is a pacemaker. And the breathing sensor, it is going to know how much breathing the human is taking, and depending upon all these values, even there is a metabolic sensors. It's going to give about the stress requirements. Even though it's like whenever if you are in stress, the blood has to flow more. So depending upon by taking all these information, the pacemaker is going to decide whether to give the impulse or not. It's gonna done within seconds. And yeah, there are, as I said, like single chamber sensors and the dual chamber sensors. Single chamber sensors are not able to do all the. They are not able to. They are not able to. They cannot do they are not able to decide how much the heartbeat should be in the daytime and how much the heartbeat should be in the night time. But with the help of dual sensors, all this problem has been rectified, and my friend is going to explain about the all the problems and drawbacks and the warnings and the pacemakers that they have.
Hi all. So far so good. If a person is recommended to wear pacemaker, he gonna wear it, and he will be happy. But in order to be happy, he should be aware of the concepts like the warnings and the precautions. And the warning spot, I have defibrillation. Defibrillation is a process in which it is the type of a pacemaker, but it's an external one. It is allowed for the pumping, for the beating of the heart, but it is quite related to the tachycardia. As one of my friends said that defibrillation is the process related to the tachycardia, and the pacemaker is related to the bradycardia. And pacemaker has nothing to do with this, and defibrillation has nothing to do with the slow heartbeat. And defibrillation is the process which involves the 360 watt per second of power. So once it has been tested in the lab on the pacemaker, so it works in an exact way, and it doesn't lose any property. So whenever possible, it is better to disconnect the pacemaker and then test the pacemaker. That's the reason why I said that the defibrillation and or the cardioversion. And the next we have line powered equipment, and one should be aware of this because we can see the pacemaker leads there, and it is quite into the myocardia, which is a middle membrane of the heart. It is a very sensitive part of the heart, and the lead should be very carefully handled there, and the person who wears should be very careful, and also the physician who is going to design should be very careful. And next, the electrosurgical units, and I mean the electrical surgeons are nothing but the electronic equipments that are in the vicinity of the person. Those should be grounded when the surgery is going on, because as I said that pacemaker leads are very sensitive. It may affect on that, and the person may even lose his breath then. And coming to the precautions, I have like random failures of the battery depletion and all that. And the battery used in this the lithium iodide, and other than that we cannot use the other things. And we better prefer for the bipolar LEDs, as these have more resistance for the magnetic or electric waves. Environmental precautions, and one should be very careful while handling it, and the spilling of fluid on the machine or the pacemaker is not recommended, and it may act in different situations depending on the temperatures. And the adverse effects of this are if it is not controlled well, there is a chance to getting of a disease called tachycardia or asystole. And then concluding. Okay then.
Thank you.